Most vectors that you will encounter will be non-parallel. There are two types of non-parallel vectors you will see. The first one is perpendicular. When vectors are perpendicular, is draw your resultant vector by using the parallelogram method or tail to tip. After you draw your vector, calculate the magnitude of the resultant vector using Pythagorean theorem. And lastly, since vectors have direction, you need to calculate direction using tan theta. So in this first example, pause the video and draw your resultant vector, either using parallelogram or tail to tip method. If I use the parallelogram, we know that we have a vector going north. We have another vector going west. I'm going to shift the north vector parallel, same magnitude, same direction. I'm going to shift my west vector up, same magnitude and same direction. Remember, the resultant starts from the tail and goes to all the tips. This is my R. So we know the north vector is 5 meters. We know the west vector is 9 meters. So this becomes a right triangle. So we're going to use Pythagorean theorem. So r squared is equal to x squared plus y squared. So r becomes square root of 9 meters squared plus 5 meters squared. So if you punch this into the calculator, you should get approximately 10.3 meters for your resultant vector. So this right here is my magnitude. Now I need to find my direction. In general, we measure from the east or the west. You could also measure from the south or the north, but in general, we go from east to west. Since this vector is going to the west, I'm going to start from the west and go to the north. So this is the angle I'm going to look for using tangent theta. Tangent theta, remember, is opposite over adjacent. Since 9 is next to my theta, that is my adjacent. My 5 is opposite the theta, so that is opposite. So I take the inverse tan, so tan inverse 5 divided by 9 meters. This is equal to 29 degrees. After that, I need to give a direction. So this is going northwest. Remember, the second direction is where we are starting. The first direction is where we are going to. So we are starting from the west and going north. So for a vector, it must have magnitude and it also must have direction. Pause the video and calculate the resultant vector. This is very similar to the previous slide. So in this example, I'm going to draw the resultant vector using the tail to tip method. It doesn't matter which vector you start with. I'm going to start with the east vector, so I draw my east vector with magnitude and direction. From the tip of the first vector, I am going to draw my second vector, which is going south. My resultant vector will start from the tails of the first vector to the tips of the final vector. So this is my R. We know this is 15 meters per second going east, and my south vector is traveling at 5 meters per second. So again, this is a right triangle, so I could use Pythagorean theorem. So R is equal to x squared plus y squared. Take the square root. This is equal to 15 meters per second squared plus 5 meters per second squared. Take the square root. If you plug it into your calculator correctly, you should get around 15.8 meters per second. Again, this is our magnitude. We need to find the vector, so we need to also calculate for direction. Since we are traveling east, we're going to measure from the east going to the south. So we're going to start at the east and we're going to go south. In general, you measure from the east or the west. So I could use tangent theta, which is opposite over adjacent. Opposite the theta is 5 meters per second. Next to my theta is 15 meters per second. I need to do inverse tan. 5 meters per second divided by 15 meters per second. If I do that, you should get approximately 18.4 degrees. Now I need to give direction. Since I'm measuring from the east, going to the south, my east is my second direction, where I'm starting from, and south is my first direction. This is where I'm going to. So now my answer has a magnitude, which is 15.8, and a direction, 18.4 degrees southeast. You could also use sine, cosine to solve for theta, but if you make a mistake with your r, your angle will also be incorrect. Pause the video, draw your resultant vector, and calculate it, and check your answers. So first thing you want to do is draw your resultant vector, either using parallelogram method or tail to tip. First vector is going west, so we know it's going in that direction. The second vector we know is going north. So I'm going to use the tail to tip method. I'm going to go north first. Again, it really doesn't matter which one you start with. From the tip of the first vector, I am going to go west. So my resultant vector will start from the tail of the first vector to the tip of the second vector. This is my r. So this is 30 newtons, my x. My y is going to be 45 newtons. So I could solve for r using Pythagorean theorem, which is x squared plus y squared, and we're going to take the square root. So this is going to be 30 newtons squared plus 45 newtons squared. Take the square root, and if I do that, you should get approximately 54.1 newtons. Now I need to find my angle. So we could find this angle if you like, or we could find, if I draw my parallelogram, it is going west, so this is my angle. I am going to find the bottom angle. So if I draw my parallelogram, I also know that this side is 45 newtons. So I know I could use tangent theta, because if the opposite is 45, these are parallel, so the bottom one is 30 newtons. So this is going to be opposite over adjacent, which is 45 newtons divided by 30 newtons. Take the inverse tan, 45 newtons divided by 30 newtons. You should get 56.3 degrees. Since I did the bottom angle here, this direction that I'm going to put in is going to start from the west, go to the north. So it's northwest. If I choose the other angle here, I could put tangent theta again. Tangent theta is still opposite over adjacent. But now my opposite, this theta, is going to be 30 divided by my adjacent is 45. And so if I do my theta, I am still going to get 33.7 degrees. And this one will be west north because I am measuring from the north going to the west. And if you notice, this is a right triangle. So this angle plus this angle should add up to 90 degrees. Either answer is correct, but you must give the correct direction. In this example, more than 2 vectors are given, but all the vectors that are given are either parallel to each other or perpendicular. So the first thing I'm going to do is I'm going to simplify this. Any vectors that are parallel, remember, you can add or subtract once you account for direction. So we know the first one is going north. The next one is going east. The third vector is going west. The fourth vector is going south. So I could add all the parallel vectors to make one vector. So in the y direction, this means to add summation. My y total is going to be my north vector plus my south vector. So my north vector is going to be positive, so that's going to be 10 newtons. My south vector is going to be negative, so I'm going to subtract. You could do a plus, minus 15, or minus 15. So my y vector is negative 15 newtons, or 15 newtons south. My sum of my x total is going to be my east vector plus my west vector. My east vector is going to be positive 5 newtons. My west vector is going to be negative 27 newtons. We have to account for direction. So this becomes 22, negative 22 newtons, or 22 newtons west. Now we have 2 vectors. So you could use the tail to tip method or the parallelogram to solve for the resultant. This time I'm going to use the parallelogram. So my y vector is going south. My x vector is going to the west. So I draw my vectors, and now I'm going to shift them. My west vector, same magnitude and direction, is going to be shifted down. My south vector is going to be shifted to the left, same magnitude and direction. My resultant starts from the tail and goes to the tips. This is the R I'm going to solve for. So we know that x total is 22. It is the total x, not the individual x. And my y is 15. So I could solve the resultant using Pythagorean theorem, because y, this is a right triangle again. So r is equal to x total squared plus y total squared. Take the square root. So 22 newtons squared plus 15 newtons squared. Take the square root. This becomes 26.6 newtons. Now this is my magnitude. Now I need to find my direction. I'm going to measure my direction from the west, going to the south. And again, you could go from south to west. It really doesn't matter. You just need to write the proper direction. Since I'm measuring it from the west, my tangent theta is still opposite over adjacent. Opposite this is my 15 newtons. Next to is my 22 newtons, because it's next to my theta. So if I do my inverse tan, it becomes 34.3 degrees. Since I'm measuring from the west, going to the south, it is southwest. So this is my direction.